All right, welcome back to pre-calculus. We are going to continue looking at some trigonometric identities. I don't know, I always found these could be kind of fun, so your mileage may vary, but I liked these when I was doing them. Um, so let's see, in this case, simplify the expression, write the final form with no fractions. Okay, so what are they asking us to do here? We have cosine squared plus 1 all over sine x plus sine x. Now, I don't really know what they want us to do, but since we have two fractions that we're adding together, my guess is going to be, how about we get common denominators? So we're multiply by sine x over sine x. Okay, so we're going to have a cosine squared x plus 1 plus sine times sine is going to be sine squared x, all divided by either now common denominator, so it's just over sine x. Sine squared plus cosine squared, you guys are going to remember that forever. And it's going to be 1. Actually, let's go ahead and not skip a step. So it's 1 plus 1 over sine x. So we can say this is 2 over sine x. Now, they wanted me to write this without a fraction, so I'm going to guess that they really want this to be 2 cosecant x. That's a guess on my part. Not sure that's what they want, but since they didn't want a fraction, I'm going to guess that's what they wanted. So they want 2 and then cosecant x, and let's hope for the best. All right, that was exactly what they wanted. So we'll continue. Okay, I'm very likely to lead you astray at this point. If you fall into the darkness, you'll be eaten by a grue, and that'll be that. So let's see here. We have following the proof. Okay, in this case, they want us to do the rules. All right, so this is a little bit of a pain. So we have secant to the fourth x minus secant squared x is equal to tangent squared x plus tangent to the fourth x. Okay, now I've got secants and tangents here, and usually when I have my sine squared plus cosine squared is equal to 1, if I divide everybody by cosine squared, okay, we're going to get that sine squared over cosine squared is equal to tangent squared plus 1 is equal to secant squared. Okay, so that's kind of what I'm looking for here. My goal, though, is look at this. I've got secant to the fourth minus secant squared. Is that what I have? Secant to the fourth minus secant squared is equal to tangent squared plus tangent to the fourth. So the goal is I want to aim for this side. Well, I have a feeling that this might be useful later on. So why don't we do something like this? What's common to my left-hand side? Again, remember, we're only dealing with left-hand side. We could also deal with the right-hand side. We only want to deal with one of them at a time. So what my first step here is I'm going to factor out a secant squared of both sides here. So we have a secant squared x minus minus 1. Minus 1 here, okay? And multiply it back in, we get back to what we started with, okay? Now, what are we looking for here? We are looking for tangent squared plus tangent to the fourth. Okay, well, what could we say? We could say something like secant squared is really tangent squared x plus 1. And then secant squared minus 1. Well, if I go ahead and swap this negative 1 in the other side, we could also have tangent squared x is equal to secant squared x minus 1. So I'm going to put in a tangent squared x is equal to a secant squared minus 1. So this is going to be a tangent squared x. And then when we go ahead and FOIL this out, we're going to have a tangent to the fourth, tangent squared times tangent squared, minus, looks like a tangent squared, plus. And then the last thing I want to do is use the commutative power of addition. So what the heck is that? That's saying that 2 plus 3 is the same as 3 plus 2. Okay, we're allowed to do that. Tangent squared x plus tangent to the fourth x. And that's kind of what I wanted to show. Okay, so let's see if we can't look at my steps here and see if we can't change the put in like a trail of breadcrumbs here so we can find ourselves back out of the darkness and not get eaten by a grue. So what rule do I want to say here? I think I want to say that's an algebra step. Okay. And then we have 1 plus tangent squared. That kind of lines up with what I wanted to do next. Tangent squared plus 1 times tangent squared. Okay, so rule. And what we want to do here is say that's a Pythagorean identity. And then rule 3, notice what we did to get rule 3 is we multiplied this tangent back in. That was an algebra step. So that was an algebra step. I think that's what we're trying to say with this. Okay, and again, don't quote me on this. I am just as likely to start missing a step and miss one. It happens. Okay, so we might have to do this several times to get the right answer here. So I'm going to go ahead and say continue and move on to the next one. Okay, by the way, grue is this word. Okay, so if you know what I'm talking about, then you're probably the same age as I am, but this was prominently featured in the first video game I ever played. Okay. If your torch went out, you were eaten by a grue. Okay, so here we have cotangent squared and secant squared minus 1 is equal to 1. Again, not an equation. That's a couple of sections later. This is an identity. So we want cotangent squared x times secant squared x minus 1 is equal to 1. So what I want to do here is I want to say, oh, look at this. We are going to want to get 1 on the left-hand side here. Okay, you could start with the right-hand side too, but I think that looks a little bit more complicated. Okay. Let's see here. Cotangent, this is probably not going to be the correct decision to go in. This is going to be cosine squared x over sine squared x. Okay, what's secant squared? That's going to be 1 over cosine squared. Okay, minus 1, maybe. Okay, that's 1 over cosine squared. So that's something that could work. Okay, I'm looking at my options here, and I kind of like cotangent squared and tangent squared here. So let's go back and remember what secant squared is. Tangent squared plus 1 was equal to secant squared. Okay, so we had tangent squared plus 1 was equal to secant squared. Okay, that's going back up to this idea. Okay, so if I go ahead and subtract 1 from both sides, we'll have tangent squared x is equal to secant squared x minus 1. I kind of like that. So we have tangent squared or cotangent squared x times secant squared x minus 1, secant squared x minus 1, which was cotangent squared x times, what was secant squared minus 1? That was tangent squared. What's the relationship between cotangent and tangent? And they're reciprocals. So if I multiply them together, that should be 1, just because they're reciprocal powers. So let's see if we can trace back what we have here. Okay, so the first thing we did was, I think we did a Pythagorean identity where we said secant squared minus 1 was equal to tangent squared. So we're going to go back and say that's a Pythagorean identity here. And then we said cotangent, and that was cosine over sine. And then, so let's see what rule that is. I think that's going to be, I don't want Pythagorean. Let's go with quotient. Okay, that means divide. So let's go ahead with the quotient rule of cotangent is equal to cosine over sine. And then we'll go ahead and do the next rule, which I think is algebra. We can just multiply these together and cross, divide these guys out and say, I think that's an algebra. That might be reciprocal, but I think let's bet on algebraic. Okay. And then we'll check to see if our answer is right on that one. Hey, look at that. We got a green mark. Okay. So again, if you didn't get the exact rule that they got, I completely understand that. That is not like I said, this is the least bad option. So yeah, there's a bit of frustration going through with this, but just to understand that when you guys have to go in and do your quizzes, the person who's grading them is me. So like when I'm seeing your trail of tears through, or your trail of misery through your identities, we could we can go ahead and check to make sure what's going on here. Okay, I don't want to trivialize that there was a horrible humanitarian disaster that Andrew Jackson put into place. Okay, so let's not make light of that. Okay, my apologies for that. So let's see, next one. We have 1 minus cosine squared x times a secant x is equal to sine x times tangent of x, right? And let's see here. So what we're aiming for is we want 1 minus cosine times secant is equal to this bit over here. Okay, so you can't, again, it's not an equation. We're not allowed to touch, like if we start with the left-hand side, we are stuck on the left-hand side. We can start with the right-hand side, but since the book tends to want us to go with the left-hand side, let's start with the left-hand side. Okay, so let's see here. Okay, well, why don't we start with sine squared plus cosine squared is equal to 1. So sine squared would be 1 minus cosine squared. Okay, so instead of 1 minus cosine squared, let's go ahead and abbreviate that with sine squared x times secant x. Okay, so all I've done is replace that. That was a Pythagorean identity. Okay, secant, that's going to be 1 over cosine. So we have sine squared x times, that's 1 over cosine x. Okay, let's go ahead and move this out. This was a reciprocal. Okay, so we have sine x over cosine x, because that's how fractions work, times 1 over cosine x. And then let's see, what are we aiming for? How about we say, I don't like that. Let's see here. Secant is 1 over cosine. Well, secant is 1 over cosine. Let's try a slightly different tack here. So let's go back to this 1 over cosine. Okay, 1 over or minus cosine rather. 1 minus cosine squared x. Okay, times secant, but let's call secant 1 over cosine x. Okay, that's a reciprocal identity. So we've got 1 over cosine x times, and then we've got cosine squared x over cosine x. Okay, there's a minus in here. All I did was multiply through that. So that's going to be secant x minus, how about cosine x? Can we do that? Is that what we're looking for? Nope, still don't like it. Let's see. Well, I do kind of like the sine squared x thing going on here. So why don't we pick the sine squared x? So why don't we go with this and say, okay, I like sine squared. Okay, that was Pythagorean. Okay. Okay, so we've got sine squared times 1 over cosine. Now what do we want to do with that? Okay, when I want to multiply them together, so let's see, we've got 1, we've got sine squared times secant x. Okay, and what are we trying to look for? We're trying to, I've got it. So this is sine x times sine x times secant, which is really 1 over cosine x. So that's really going to be sine x times tangent of x. Sine over cosine would be tangent. So let's see, what rule would this be? This would be reciprocal rule. Because look, we're changing the secant into a cosine. So that's reciprocal rule. And then we're going to go ahead and use an algebraic step where we just pretty much broke the sine squared into a sine times sine. So we're going to break that and call that an algebra rule. Okay, and now the fact that we have sine over cosine, we're going to bring that into a quotient rule. Okay, and I will check that one. Okay, I was afraid I was going to be in my groove on that one. So we'll go ahead and say continue, but I'm going to go ahead and stop this video because we have a few left, but we'll see how we go with that. Okay, so I'll see you in the next video.